Alright, hello once again, Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD 1112 Application Programming with Java class, I'm doing a series of video presentations based on the two textbooks that are being used for the class. First of which being, as you can see here, Java Quick Syntax Reference, a 23-chapter book of which I found a PDF online with 22 of the 23 chapters. I have done the first 16 chapters, which puts us in the home stretch, and we're in Chapter 17 now talking about interfaces. Again, much of the material that I'm covering may seem, oh, we had that in C#, we talked a little bit about that in JavaScript, etc. Some of it that we've talked about, especially in the last several chapters when we've been talking more object-oriented programming, might seem foreign to you. When I get done with the 23 chapters that are in this book, all right, when I get done with them, I'm going to go and write a series of programs, and hopefully it'll allow me to demonstrate a lot of these concepts that have been in the book, all right, and some that have not been in the book. So, Chapter 17, all right. Interface. An interface is a type that, as it says, decouples interface from implementation. Before we even go on, if you remember back in chapter, what was it? 12, we talked about inheritance. And we mentioned that one of the things about Java, like C#, is it only allows single inheritance. So in other words, you can only inherit or extend from one other class. But what if there's other things that you want to basically extend from? You can't. But you can create what are called interfaces. And an interface is sort of like a class, but you can only define it in a certain way. The advantage of an interface is, although you can only extend one class, so you can only have one superclass, you can implement as many interfaces, 0 or more, as you need. So as it says, an interface, I like this definition. It specifies a contract between the class that implements the interface and the interface itself. What that means is the interface says, I'm going to provide this stuff for you, and the class says, okay, and I'll agree to use it, be bound by the terms that you're setting. All right. So again, hopefully, as we start at least, that makes at least a little bit of sense. Okay? You're going to have to see this in action, I believe, before it really makes a lot of sense. Go. All right. So it says here, the code block for an interface can first contain all signatures for instance methods. What that means is interfaces, and this is not a good example. Why? Because an interface typically starts with the letter I, meaning that it's an interface. All right? In many ways, this almost looks like it would be a class. Well, it's got interface instead of class, but notice it has here an empty method. That's what's called a method signature. What that means is that any class that implements this interface must create a method called myMethod, and that method must return an integer. Interfaces can also hold constants. Any field that you create in here is automatically, even though it doesn't look like it, is declared as a static final. I think you can actually put static final in there if you want. I am going to go through and give you a much more detailed interface example in a little bit than the one that's shown here. All right? So the author says the example below shows an interface named comparable, which has a single method called compare. So the class called circle implements, you implement an interface, so it implements comparable. What that means is this class must include a method called compare that has an object passed into it and that returns an integer. And there's an example. It's not telling you how to implement this method. It's not telling you what to put inside of the curly braces. But it says, since you are implementing that you must have a method by that name that takes in that value that returns that type. That's the simplest way that I can put it to you. Again, I think when you see examples that I'm going to give later, hopefully at least, it'll make more sense than that just did. All right. Comparable demonstrates the first usage of interfaces, which is to define a specific functionality that classes can share. It makes it possible to use the interface members without having to know the actual type of the class. So here's something else, because we had this thing here called circle. Now we've got one called largest, and it's also going to be implementing that interface. But notice what it returns is much different. But what it returns is either a 1 or a 0 or a -1. But it's still returning an int, so it works. A second way to use an interface, as it says here, is to provide an actual interface for a class through which the class can be used. This is more, I guess, the way that I was explaining it. So what this says is, if I've got a class that implements my interface, all right, it must include that method. It must. It doesn't have any choice. The interface type, it says, there is then used to hold the implementing class, so the class is only seen through this interface. I have shown this example before, but I do want to make sure people understand. And it may seem very simple. I type in the number 367, and I hit the, I always forget on this calculator, what is square root? And I don't know. Divide. There it is. All right. I don't know what happens magically inside of that calculator to convert 367, the square root of that, to 19.1572, etc. And I don't care. My interface, when I started it, was this. And I put in 367 into the interface. I clicked this as part of the interface. The implementation is what happened underneath the hood to give me that answer. All right? So an interface is kind of what you expose, and the implementation is kind of what happens behind the scenes. All right. The author says when you use this kind of abstraction, it provides two benefits. First, it makes it easier for other programmers to use the class. Second, it makes the class more flexible as the implementation can change. So in other words, looking at the example that I gave you, if somebody comes in and figures out a brand new way to do square roots that gives me the answer twice as fast, as long as we don't change the interface, but if the internal implementation changes, I'm not the wiser. And that's kind of what the author is saying right here. All right. An interface can contain nested types such as classes. In contrast to methods, these types are implemented inside of the interface. As it says, as an example, this can be used to provide a class that contains static methods useful for implementing classes. The nested types are only visible to classes that implement the interface and not to objects of those classes. All right. So I think we have completed yet another chapter. So before I come back with chapter 18, all right, I am going to produce this one.